Cubase 9.5 has new 64-bit processing, and there seems to be quite a bit of confusion about this, so let's clear this up. Under the Studio menu, if we go to the Studio Setup and then go to the VST Audio System, then we have two different options for processing precision, and that word precision is very important. But you can choose from 32-bit or 64-bit. I'm going to choose 64-bit right now. Then I would need to restart Cubase to have 64-bit set in that precision window. But what is 64-bit processing precision, and what makes it better than 32-bit, and how does it work inside of a DAW? Well, let me explain the difference between 32-bit and 64-bit processing quickly, and it was best explained to me by Philippe Gauthier, who's the author and father of Wavelab, and a guy that knows more about digital audio and math than I ever will. But it doesn't have anything to do with the dynamic range or the word length of the digital audio file that you're going to be saving onto your computer. That's still going to be 16 or 24 or 32-bit or 32-bit floating point. What it really has to do with is the precision of the mixing engine. So digital audio processors, including DAW software, use a series of bits to calculate the values. So a 32-bit engine has a value range of between 0 and 4.2 billion values. And if we use the 2's complement method, that's plus or minus 2.1 billion values. So what does that mean in digital audio? Well, let's take a simple number like 2 and let's halve the gain. In other words, we're going to take the number and divide it by 2 to get a value of 1. Then let's take that value and double the gain. So mathematically, we're going to multiply the value by 2, and we end up with 2. And 2 does equal 2. So we took the original value, cut it in half, then multiplied that value by 2, and we get the same number we started with. But then things get a little bit fuzzy. Let's take another simple number like 3, and let's halve the gain. In other words, we're going to take 3 and divide it by 2, and we end up with 1.5. But an integer is required here, and so the digital audio processor rounds 1.5 to 2. But then when we take that value and we double its gain, in other words, we're going to take 2 and multiply it by 2, we get the value of 4. Now, 4 does not equal 3. So in the case of number 3, we don't end up with the same number as we put in, even though we're using the exact same calculations. This is called a rounding error, and a DAW or audio engine is making a lot of calculations, and sometimes it has to round things up and down. And when a DAW is processing, summing, or mixing any audio signals, you end up with quite a few of these rounding errors, and sometimes they even out and sometimes they don't. But how do you increase the precision of an audio engine? Well, to do that, you have to increase the number of bits. So 64-bit has a value range of between 0 and 18 quintillion values. Or if we use the 2's complement method, we end up with plus or minus 9.2 quintillion. So to increase the digital audio precision, you have to increase the resolution by adding bits. And the more bits you have, the fewer rounding errors you're going to have, and the rounding is going to become less of an issue, resulting in higher precision. And just how much higher? If we look at those two different values, 32-bit at 4.2 billion values, or 64-bit with 18 quintillion values, the actual difference between those two numbers is double the precision. So it doesn't have anything to do with the dynamic range of the audio. It instead has to do with the way that a digital audio processor processes those bits to get the values. And the more bits you have means you have a higher audio precision. Now, there is one tiny drawback to using 64-bit processing, and that is that it will take a little bit more CPU power to make all of those new calculations, but the benefit is going to be less digital fog, as Philippe likes to call it. So you'll be able to get a cleaner recording, a clearer representation of the audio, and a broader sound stage if your ears are up to the task. So that's 64-bit mix processing, and next let's talk about additions to the right zone.